Hi all, welcome to Racsinfotech. In this video, I'm going to share you Oracle RAC DBA entry question and answers. These questions I have framed are designed based on my experience. Okay, it's a part one. In upcoming sessions or upcoming videos, I'm going to share a couple of uh, Oracle RAC DBA entry questions. Also, I used to make some of the key components of RAC. Oracle RAC DBA related things. I'll make separate videos, but yeah, few of them are asked in our channel. That's Racsinfotech. Could you please share the RAC DBA entry questions and all? That's where I'm sharing this video and upcoming videos also. And a couple of people are posted in our channel. Could you please share the text and other things, right? So for them, I'm giving answer is guys, whatever the information video frame, I'm going to post videos on my channel and text I'm going to share through my blog, Anjani Apps DBA blog. Even though I put Apps DBA, but here you used to get all kind of database knowledge. It could be cloud knowledge, Oracle DBA, Oracle Apps DBA, Exadata, supercluster related things, shell scripting, OS commands, OS means operating system. It's mainly on Linux operating system. Here it is. So a lot of information you used to get text format in through this blog. Okay. And the videos, entry questions, DBA knowledge, everything I'm sharing through Racsinfotech. Okay, now coming to our video, it's a part one. So let's get started, guys. I don't want to take more time. What is Oracle RAC? Okay, what is the use of Oracle RAC or what is Oracle RAC? For that, we need to answer RAC is for high availability. Oracle RAC is for high availability, scalability, and load balancing purpose. And mainly organizations are used Oracle RAC database, okay, or else Oracle RAC database. They can use for performance management. Most important is high availability and performance. Next features is scalability, load balancing, other extra features. Okay. If simply let me explain what is the difference between Oracle RAC DBA and Oracle Core DBA. Okay. Simple guys. See here, this is database. Okay. This sits in one single database server. So if you want to manage your database on a single server, multiple users, you are having 1 or 3 or 10 users. I'm giving an example. So 4 users are there. These 4 users are trying to do some kind of data. These two are trying to fetch the data from the database. These two are trying to insert the data, storing the data. Suppose something happened in the server level. Okay, this has been crashed. These 4 users, whatever they are trying to do it, they can't connect to this DB. It means there is no high availability. Okay. This standalone database, we call it as a core database. That's different, guys. Technically, we used to call core DBA, but we call it as a standalone. Standalone means single database, single instance. So through single instance, single database, we are trying to access it, these users. For that, Oracle has been introduced real application cluster RAC. What it does mean is, what is mean by RAC is, so we have 2 servers. Both the servers you can install Oracle database instance. Okay. SID. Here we have SID instance. Here SID 1, SID 2. So 2 instances. So 2 ways to access the database. Here only one way we are having. One way. If the server level or instance level it is down, there is no way to access these guys to this database. But in RAC, what is going to happen is your database storage or database is shared by these 2 instances. It is not resides, this database is not belonging to this server or this database is not belonging to this one. So it is commonly accessed by these 2 servers. At that time, what will happen? Users, same 4 users are there. They are trying to access this DB. This is the database. Okay. Single DB accessed by multiple instances. We call it as a real application cluster. So I'm going to explain you the features of RAC. So availability, it means high availability, scalability, load balancing, and performance improvement. Okay. First one, high availability. Suppose the server level, if anything goes wrong, Okay, these users, whoever is trying to access, they will access two users from this server, two users will be accessed by from this server. Both are trying to access this database. So if the server is not available, all four users are trying to connect, or they will redirect to this server, and they can able to access this database using this instance. It is called high availability. How the users will be transferred from this instance to this instance, that is different story, guys. That is interconnectivity, some functional. We will discuss that question later. No problem. So that is high availability. So one instance is down, like one way or one door is closed, another door is open to access this database. Simple language. But in core database or standalone database, one instance, one database, like one door to access one database. If the door is closed, there is no way to access. But in RAC, we have multiple doors. I have taken two doors, but you can take 10 doors, 10 instances. So we can access this database using this one, this instance, this instance, this instance, n number of instances. Okay, that is called high availability. And the database is physical. It's a kind of your hard disk. Suppose you are having one external hard disk. Whatever the information is there in your system or in your laptop, you used to take backup from your laptop to your hard disk. So database, we call it as something like that. Okay, it is not exactly, but it is something like that to access your storage. So there is no down for your database, downtime for your instance. Okay, downtime for your instance, shutdown, startup. We are doing instances, not the database. Database is a physical server, storage, CRD files will resides. Okay, no need to go in depth. This is the difference between your RAC and standalone database. Scalability, if you want to increase the size of the storage, you can do it. Also, if you want to apply the patches, you no need to shut down complete instances. Okay, you can first shut down this instance, this server, apply the patches. During this patching activity, this instance is available to access. Once the patch is done here, you can start up this instance and down this instance, apply the patch. We are applying the patches on the instance level, software level, not on the database. Database is a physical, like storage. Storage, we are not going to, we are going to increase the storage, adding the disks. So we are using ASM storage that we will discuss later. Okay. So we are going to add the disks. If it is filled, like as of now 100 GB, it is filled up. You can add another 50 gig or 10 gig. Once it is filled, you can add one more 50 gig. In that way, we are going to add the storage. Okay. Load balancing, as I said, all four users are there. They are trying to access this database using two instances. If one of the instances failed or it is loading, so scan will be there, single client access name. This will take care of this load balancing of this request. If 100 users are coming to connect to this database, it will share the load between two instances, equally. Okay, round robin fashion, it is going to assign those requests. So there should not be any overloaded for one instance. It is internally scan will take care of it. Okay, that is high level, guys. Just if I can explain this much, you guys may have some knowledge on it. Hope you got it. And we'll go for second question. What are all the components in Oracle RAC? In RAC abbreviation, Real Application Cluster. Okay. So we are having high level components. I'm going to give you Clusterware is one component, Oracle database instances just before we have discussed, and shared storage that also I showed you, ASMR cluster file systems we can use, and interconnect. Interconnect also just before I have explained, right? We are having two instances. See, this is the database DB. This is instance 1, instance 2. Okay, both instances are internally connected. From this instance, users will access. From this instance, users will access this DB. This interconnect will help. Okay, this is internal part, guys. So interconnect will take care of this node communication, node 1 and node 2. Whatever the users are connected here, if something goes wrong here, this instance is down. This interconnect process will take care of this failed services passing to second node. That is interconnect. Cache fusion will come into the picture. Okay, if any node, this node is evicted from the cluster, interconnect will take care of it. Okay, for the existing connections. Shared storage, this one, ASM we can use, or any authorized or approved not approved, I can say certified cluster file systems, we can use it for storage. But most of the organizations are used ASM is their storage, shared storage. So this storage we can able to access from here and here. That is one component in our RAC. And Oracle database instances. As I said, this is one instance on the server. Another instance, I can say somebody will say, can I shall I install both the instances? And they say, yes, you can do it, but there is no point for high availability. Okay, the instance should be in different servers. So if something goes wrong on this server, okay, this server, how you are going to manage the high availability for RAC? Single node RAC also. In RAC, they don't have this confusion. You can use one instance, one database, cluster services like a single node RAC. You can do that. There is no point like you will not get high availability, but you will get a scalability related thing. You will get this thing, performance improvement, that you will get it, but it is not useful. That's where we can use multi-node. More than one node, you can install your database instance and access the shared storage. Okay, let us explain the cluster. Cluster is not clusterware, not the cluster. Clusterware manages the cluster environment like these two instances act together as a single node. That communication, that terminology, we call it as a clusterware. Okay, manage the cluster environment, ensuring that all the instances are aware of each other and can access shared resource. These two communicate, and these two like as a single, like a family. Okay, in a family, if you are having more than 10 people, all together there's a single family. That's where we call it as a clusterware. Clusterware is the communication, like more than one node work together accessing this database, that we call it as a clusterware. Okay, Oracle database instances, simple. Each node we are going to install the database instance. It holds your SGA plus memory and the background, couple of background processes, that we call it as a individual. This is one instance, and this instance is having its own memory and the busy processes. This instance it's having own memory and its background processes and daemons. All together, these two instances work together. That work together functionality, we call it as a clusterware. And shared storage. So from this server and this server, both commonly we are going to assign the shared storage. Okay, that shared storage we are using ASM, and I'm giving an example. Few people might use some other storage also, third-party storages. That's different story. And common storage used by all RAC nodes for storing database files or database information. Okay, database is nothing but your combination of your data files, control files, and redo log files. We call it as a database. So these are all here our CRD files, control, redo log, and data files will store. These two instances commonly accessing these two. That is called shared storage. Interconnect, if this node is failed, whatever the connections are whatever the connections are there here, it should transfer from here. How it is going to transfer? Through this interconnect. So interconnect is a private connection between these two nodes. If any one of the node is failed, the existing connections will transfer through this interconnect to availability node. Okay, these are all the high level components, guys, of RAC components. Hope you got it. Third question. What is the role of clusterware of the file? In our clusterware, we just discussed, right? Clusterware manages the environment, ensure all the instances each other and sharing the resource, right? In our clusterware, we have main components OCR, OLR, and voting this. These are all the very important files in our clusterware. OCR is nothing but Oracle abbreviation, Oracle Cluster Registry. Okay, it's commonly holding the information. It's throughout the nodes. It is holding like communicate. What I'll give you the example. Like we are having suppose 2 node or 3 node. I'll take 3 nodes. This is DB, commonly accessed by 3 nodes, N1, N2, N3. This clusterware OCR will take care of all 3 nodes together. Clusterware we call it as, okay. This clusterware, all 3 nodes remotely, or all these information will registered with this OCR file. Okay, stores the configuration information for the cluster, including information about nodes, node 1, node 2, node 3 information stores in your OCR file, and the resources, whatever the we have given all the, I'll show you that physically in our lab session. Okay, all the components, cluster components information, I'll show you those. And the databases, whatever the database names we have given, those information, what is the DB name and other information, I'm going to share you in next couple of seconds. All this information stored in your OCR file. Okay, we can store OCA backups. It's not OCA, OCR backups in ASM or cluster file systems. Okay, we can store this OCR backups in our ASM file. Oracle strongly recommend to use your OCR backups and voting files, voting disks backups in your ASM file system or cluster file system. It is certified by the cluster. Okay. Okay. How we are going to take the backups and other things? Let me explain it. Okay. Now it is not going. Let me delete it. Cool. So how to check OCR backup? How you are going to check the cluster, it is properly there or not, all those things. These OCR backups we can take in two ways. One is automatic, another one is manual method. I'll show you those commands also. And how we are going to restore if the OCR file is missed, OCR backup is corrupted, OCR backup is lost, how we are going to restore it. That I'll just explain it. This is also interview question, guys. OCR check is the command to check your OCR backups and other things. Okay. And if you want to check location, OCR config -backup location, it is going to check this backup location, whether the backup is existed or not. And if you want to restore the backup from this backup location, use this command OCR config restore and give the location of your backup file. Okay. If you want to see the OCR backup, check OCR config -show backup option, or this is manual backup, whatever you have taken. If you want to check auto backup, OCR file will take automatically every 4 hours. Okay, OCR config -show backup space auto. If you are mentioning auto, it will check your auto backup information. And if you want to take a manual backup, you can use -manual. All this information, guys, I'll post in my blog. You can go through it, all these commands. Okay, the main purpose I'm going to explain this OCR, Oracle Cluster Registry main. It holds the cluster and database information. High level I have given already. So in depth, cluster database instance to the node mapping. What are all the nodes are there which are mapped in the cluster? Okay, all the information, node 1, node 2, node 3, all the database related information cluster level it is going to store. And how many nodes are exist? By using these OLS nodes, we can get that information. All the resource profiles it is going to store. All the listeners, CAN listeners, local listener information, VIPs, CAN IPs, all the services, database connectivity services, all those things will store in your OCR file. And ASM disk groups information, volumes, file system, it's all about storage. Which disk is stored in which disk group, all those information it is going to store. And OCR's automatic and manual backups information. As I said, right, this one, if you want to see OCR's automatic backups information, you can use this. If you want to check manual backup also, you can use OCR config-show backup or OCR config-show backup auto. These two commands will help you to check that information. If somebody will ask you how to restore your OCR backup is failed or corrupted or something happened, how we are going to restore from the old backup? You can follow these commands, guys. I don't want to read these commands, right? Better you guys can able to read it. Nothing much. As practically, we can show it in our upcoming videos. Okay, these are all one. First, we need to stop the cluster, then use the restore command. Very simple, two commands. If the cluster is not stopped, some errors or warnings you faced, what you need to do? You need to stop forcefully. Okay, and then if any issues while restoring, you can use this command, start cluster in exclusive mode. And specific instance, if you want to do node by node, you can do that as well. One node and second node. These are all the commands, guys. Okay. After finishing up those things, you can able to use different commands. Finally, after you restored, you can use this command to verify the OCR integrity. Oracle Cluster Registry information is properly there or not. If that any warnings or errors, we can able to find out by using this command. Okay, that's all about our OCR file importance. Okay, next one is voting disks. Voting disks are very important as part of our cluster heartbeat checkup. And if one of the node is failed from or evicted from the node, how it is cluster will knows this voting disk will take care of that kind of information. See, what is voting disk? Voting disk ensures that Oracle RAC instances can determine which nodes are part of this cluster and participating in the database operations. Okay, any node failure events occurred based upon this voting. If you don't have the voting disks, you have not configured the node failure information in determining these things will not work out. Okay, how the voting disk, some of the interviewer may ask how many voting disk we can use. Okay, what I can strongly recommend, you can use odd number, 3, 5, 7, like that. Up to 32 voting disks you can maintain your cluster. So if you are using only one voting disk, that is external redundancy when you are using as part of your ASM redundancy models, external, normal, high redundancy, right? Simple, right? I'll give you external redundancy means you are having only one failover group, FG. It's external, so you can use only one voting disk in that case. This is external redundancy. When you're using ASM, normal redundancy mode, you are using two failover groups. In that case, two groups is there. In that case, you need to use three voting disks because every time the cluster, how it is going to take majority of votings. Suppose one is there, even if it is present, it will present 100%. There is no sharing, but two nodes are there. For this, if it is present 50% vote, and this is present 50%, total 100%. If it is failed, it is for 50%. So how the node eviction has been configured in our cluster is more than 50% vote should be present in a cluster. Then only other nodes it treat as a failed. Even if it is not failed, it is failed to vote, like I am present kind of one. In normal redundancy, you have to have three voting disk. You have to. That is the standard format. In external redundancy, we are using three failover groups. In that case, you have to use five voting disks. Failover group 1, failover group 2, failover group 3. If you are keeping 3, there is no majority of voting, right? If two nodes are failed, how it is going to identify the cluster existence also. Okay, that is different choice. So that's where you have to use five voting disk when you're using high redundancy. At that time, all these things this voting should take more than three disks are voted. Okay, remaining two, if it is voted or not voted, that is different story. Okay, three voted means cluster is healthy. Here two should be vote, cluster is healthy. One more voting disk we have, keep it extra. Even if it is not voted, cluster won't care about that. Okay, it need more than 50% of attendance, not 50, more than 50%, 50.1. Okay, exact 50 also it is not going to take. How we are going to calculate that? Based upon your redundancy, which kind of redundancy you are using, that we have to give those many voting disks. That is very simple, right? See, voting disks are crucial for preventing split bind scenarios, which can lead to data corruptions. This is one. And what is mean by the split bind? This we can able to learn in our upcoming session. So it is going to extend it. We'll take it step by step. Okay. High level voting disks, heartbeat checkup in your cluster. Okay, how we are going to define the voting disk, that is one information here, and how we are going to take the backup of voting disks, other commands. I'm going to share it here. Okay, you can pause the video and then read this theoretical information for voting disks, guys. See, mainly we can use it for node failure to determining the information, node failure to avoid the node failures, identifying the node failure informations. We can use this voting disks in our cluster. Okay. See here, a node must be able to access more than half of the voting disk at any time. That's why we need to maintain odd number of voting disks. Somebody will ask you why we need to maintain odd number of. This is the answer for that. Okay, a node not able to do so will be evicted from that cluster. If the node is not able to attend that or enter the presence, that will say it is evicted from that node. Okay, evicted from that cluster, not the node. Okay, here we can say it will store node our voting files will store, our voting disk will store the static information and dynamic information. Dynamic information is disk heartbeat every time. Okay, and the static information is about node in the cluster. The nodes are presented in the cluster. These two information stores in your voting disk. This is also another interview question. Okay, how to check the voting disk information? Check CRS-CTL query. Okay, from your grid user, you can able to use it. Dollar prompts for your user normal and hash prompt from your root user. And if you want to replace the new voting disk, you can use this replace voting disk in ASM disk group. If you want to delete the voting disk information, you can use CRS-CTL delete. Very simple commands. Okay. If you want to add a voting disk to the path, use this command. And the last one is OLR. Okay. These things, OLR will help for your OCR. Each node, it's a node specific. OCR is a cluster level. Complete all the throughout the cluster level it is going to take. But OLR is node specific. If you are using 3 node, each node it's having local registry. Oracle local registry. All the node information locally. OCR file will read these OLR files to get the local information. Simple guys. See, we are having 1 node, 2 node, 3 nodes. Okay. OLR will take care of locally. OLR1, OLR2, OLR3. So OCR is common for all 3. This is a cluster OCR. So this OCR backups will connect with this OLR and connect to this information stored here. This OCR will connect to node 2. It read the OLR backup from the node 2. Gather that information stores into this OCR file, and this OCR file is connected to node 3, gather the information stored it here. So it is a global, okay, cluster level backup, but OLA or OLR is a local registry, node level, node specific backups. Okay, these backups will help for your OCR. That is the difference. We can use these 3 tools to get OLR and OCR backups information. Okay. OLR resides on every node in a cluster and manage the Oracle cluster configuration information for each particular node. Individual node level, cluster level information holds by OLR. All the cluster level, all the node information hold by OCR. That's it. That is the difference. Okay. You can go through this theoretical part and how to check your OLR backups. Use OCR check -local. If you can mention -local, it is nothing but your OLR backups. And how you are going to take the backup of your OLR, OCR config space -local space -export and the file name. It will give you the file name whenever you are querying. That file name you can give and that will take the backup. And if you want to restore your OLR file by using import, you can do that. And if you want to take this is automatically when your OCR file backup is taking right at that time, automatically OLR file backup also it will take care. There is no specific thing. If you want to take manually, you have to give this command for OLR files backups. OCR config space -local -manual backup. That's it. And if anything goes wrong in your local node level backups, okay, you can use these commands to restore that local OLR backups. That is the major major differences between OCR, OLR, and voting disks. This is very, very important, guys. Each and every interview, most of them, 99%, you may get one question related to this. Voting disk, OCR, and OLR. Okay, that's where I have explained most of the information in a single question. Okay, next, how does Oracle RAC provide high availability? We already explained in the first question. It will using interconnectivity option and also multi-node, we are going to use it. In that way, it is going to provide you the high availability, allowing multiple nodes to access the same database. This is the scenario, allowing the multiple nodes to access same database or single database. That's where, see here, we are having 1, 2, 3 instances, multiple instances are accessing shared storage or shared database. One database, DB1. This is instance 1, instance 2, instance 3. From 3 instances are accessing single database. In that way, RAC is going to provide you the high availability. All 3 instances in a cluster. All 3 together acting as a single system. That we call it as a clusterware. Okay, these clusterware level, OCR is the master. It is going to take care of this clusterware. If anything, no, any one of the node is failed, any one of the node is evicted, the backups, everything is managed by this. Okay, high availability in that way. Okay, node interconnect, one of the component, and voting disks will be there to check the heartbeat of all these nodes internally. Okay. Okay, coming to this question, how it is going to provide you the allowing multiple nodes to access the same database, ensuring that if one node fails, other can take care over the workload. How it is going to take other nodes will take care interconnect. By using interconnect, it will take care of failed node workload. That is the way a rack will provide you the high availability. Another feature. Oracle Clusterware to monitor the health of the cluster. I just shown you diagram, right? Node 1, 2, 3. Clusterware. Implementing the fast failover where services are immediately redirecting to another availability node. In that case, if anything failed, okay? Interconnect high availability, VIP we can use. As part of that architecture, we will discuss. VIPs will take care of those things. Node failures. Okay. And coming to next question, what is the difference between Oracle RAC and DataGuard? Most of them may have the clarity, but few of them doesn't have. Or even DataGuard, when we are trying to learn Oracle DataGuard, we can say high availability. We should understand what is the main difference between Oracle RAC and DataGuard. Simple, guys. So RAC, we already know. We are having 3 instances, single database, right? If this instance is not available, this server is not available, users can able to access from this node or this node. This is high availability. High availability. If you want to apply the patch on this database, first you can shut down this node, apply this patch and start up. Then you can shut down this node, apply the patch and you can start up. Then you can shut down this. So rolling fashion, we can do the patching. So there is no downtime to access this database. That is high availability. You should not get single minute or single second down time for this database. Always available. If this node is not available, these two is the ways. 3 ways we are having to access this. Okay, that is high availability. Coming to our data guard. So we are having one instance, one database, one server. So another server, one instance. This we don't have any database, single database. Okay, no database. This is the database for this database. This instance is trying to access this database and this is data guard configuration. This resides in one data center. This will be there in another data. It is recommended. You cannot keep both the things in single data center. Okay. So this is a primary site. This is a standby site. Suppose I am using data guard standalone database. Both are using 2 instances we are saying, but this is passive mode, always mount mode. It should not be, both should not be open at a time. That is one rule for data guard. And when anything goes to this database, any single piece of information storing this database, immediately it needs to be sync or replicate. Sync is enabled 24/7. Suppose this database, something goes wrong, this instance or server is not accessible. At that time, this standby server act as a primary server. So during this time, there could be some delay. It could be 10 minutes or it could be 30 minutes. You can take 5 minutes also. Converting the standby to primary. There is the downtime. To make this primary is not available. The standby, we make it as a primary. This will take time. But the same database, we can access from another data center with this instance. Okay, there could be some data loss when somebody is trying to write the information to this database, the server is failed. Whatever the information is, uncommitted information will be there. That transactions may loss. There is a chance to lose that information, but here there is no chance to lose the information. There is no single second downtime. If this instance is failed, these two are available. This can able to access it. So that is the difference, guys. Single database, we can access it using 2 different instances, but it is not accessing same time. But we are having high availability compared to why people are using RAC and why people are using data guard. This, if you want to maintain, if you want to use the main huge high, what I can say, multinational companies, entrepreneurs, if they want to use it, they can go with high budget, high load servers, high capacity servers. They can go with the rack. Licensing wise, maintenance wise, high costs. But this one, you don't need to pay any kind of licenses for data guard. Standalone server, whatever the license you have, by using that, you can have your data guard thing. Okay. But high availability, you have to compromise on this 5 minutes delay, or you may compromise like 1 minute or 2 minutes data loss. You have to compromise, and you will have the availability within 5 minutes. You will get another high availability, but it is not a exact high availability. This is high exact high availability. And if you want to increase the performance, you have to add the memory here and there, and maintaining these things quite sim or quite what I can say, less price compared to this rack environment. That is the difference, guys. Major difference. Data guard and rack. That is the difference. Even for data guard, you can use rack environments. Same environment, same database, multiple instances. Okay. If something goes wrong in the database or the site, wherever the data center is there, all these nodes are resistant, sits on the same data center. This data center is failed or something goes wrong, then you need high availability again. At that time, we can use this data guard concept for rack. In that way also we can able to do it, data guard. This is the best option for data guard. Okay. You will get higher, performance, you will get scalability, you will get high availability, everything you will get it. Hope you got it. I think it's a high information, but I have given clear differences between those two, I hope. Okay. RAC is provide high availability and scalability by allowing multiple instances to share single database. It's a primarily or primarily used for load balancing and minimizing the downtime within the same data center. Okay, but this is two different data centers. It provides disaster recovery maintenance, maintaining a standby databases that can be activated in case of primary database failure. Standby will act as a primary. It works by replicating the data from primary database to every time the data, whatever it is stored in your primary, it should sync, okay, replicate with your standby database. That's in that way we can able to secure our production, our primary databases. Sixth question. What is cache fusion? Guys, I'm going to make another video for clear-cut cache fusion, how we are going to fix that issue, how we are going to, what I can say, identify. Okay, a lab session, that will make it another video. But here I'm going to give you the definition. Cache fusion is the mechanism that allows Oracle RAC instances to share data in memory level, in memory, okay, without the need for disk IO. When one instance modifies the data, it sends the changes to other instances. Simple. Somebody, we are having, as I said, 3 instances there. Each instance, its own memory. Okay, its own memory, SGS. Altogether, users can able to access from this instance and write the information using this memory, and they can write it. This memory level, the data is going to share as and when I have put some insert command or update command, immediately this memory level, one of the daemon is going to share, hey guys, I'm going to update so and so table, I'm going to update so and so object. That information holds by all 3 instances. If somebody is trying to connect to this instance through this instance to this database, and they are accessing the same object, it is going to say lock. Okay, that will help to identify duplication, to identify that when one instance modifies the data, it sends the changes to other instances to maintain consistency across all the nodes. To consistency, right? I'm modifying one object, same information shared to here. Okay, object is modifying by so and so, object is modified by the so and so. So that will avoid the conflicts and ensure that all the instances have the most recent data. Through all the instances, if anybody is trying to connect from here, same object, they will get accurate information. Okay, that's what we call it as a cache fusion. Cache fusion is not an issue, guys. It's just an kind of activity. Okay, It is a kind of activity. It is not an error. It is not an issue. It's a mechanism. Okay. Node eviction is an issue that we will discuss later. Cache fusion is a mechanism. It is not an error. It's a process. How it is going to make a consistency of our data. Okay. Next, explain the role of interconnect. Okay. As I said in previous also, if you are having multiple nodes, three nodes we discussed, right? 1, 2, 3. Interconnect. If node is failed, how the existing users on this node connected to other nodes, availability nodes, by using this interconnect. Interconnect is dedicated network used for communication between the nodes in the RAC cluster. This is in 3 nodes in a cluster. So in between the 3 nodes, interconnect will help to communicate each other. Cache fusion communication, interconnect will helpful. Heartbeat monitoring for dealing node failures, if node evicted, for that interconnect will help. Data synchronization and locking mechanism, this interconnect will help. All 3 features help by this interconnect. That is the use of interconnect. Okay. Dedicated connection, or I can say private connection in the cluster nodes, in between the cluster nodes. How do you troubleshoot Oracle RAC performance issues? It's like different tools we are going to use it, guys. First, we need to check the load on each node by using top command. Whatever the operating system you're using, you can use vmstat or iostat. It depends on your operating systems. And then check your, if you have a OEM, go through that, and there you can monitor all the blocking sessions and the load, everything you can check it. Block logs, everything you can check it. Another way, check the alert logs. Okay, alert log files and other things. You can get to know what is going on. And analyzing the performance views such as $V session, $V active sessionist, ASH, and GC pendings. Okay, all these views, by using these things, we can able to get some of the issues, which process is making cause of the performance issue. All those things we can able to identify. These are all high level, guys. These are the high level things. You can give this information, that's enough. Like if somebody is digging you more, that comes under as per experience, we'll say it, but it's a high level. And can you describe how to add a new node to Oracle? It's a very simple. By using node add command, we can do that. By using node add command, this one, add node.sh command, and give the host name, new node number 2, node number 3 if you want to add. Simple. As of now, you're having 3 nodes. We discussed, right? 1, 2, 3 nodes are trying to access this database, shared database. If you want to add one more node, you can able to add it. How you're going to add? You can use add node command from your grid home CRS install location. Give this node name, node 4. Give node 4. Okay. Then that is going to add it. This is the process. Install the necessary software on the server. Passwordless connection, you can enable it. And the network interconnect, that is the passwordless communication you can, and VIPs, scan IPs, public IPs, private IPs, all together, and add this in DNS. Okay, DNS configuration, all those things you can finish. Then you can use this add node command that will take care of remaining. You don't need to use other things, copy the cluster and other things. Okay, add node command you can use. And then root.sh scripts, cluster level. Verify these commands. SRVCTL to check your database instance and other things. CRCTL, your cluster resources services on this node, whether it is working fine or not. This is the high level, guys. Okay, this is the command, how we need to add a node to the cluster. And the last question in this video, what is the role of SRVCTL command in Oracle RAC? We have 2 commands. One is SRVCTL and CRSCTL. CRSCTL will take care of cluster level. Okay. SRVCTL abbreviation, guys. Most of them may have an idea, but may not recall. Service Control Utility. Service Control Utility is nothing but SRV means service. CTL means control. SRV CTL is a service control utility. Use it to manage your Oracle RAC instances and the services, listener, scan IPs, ASM instance, and Oracle database instances. All you can use SRV CTL command, and then you can manage it. It is used to start, stop, configure, monitor the database and services. Okay, this is an example how we are going to start instance, how you're going to stop your database. Also, we can use dollar $srv ctl stop database -d rax db. So if you're having 3 nodes or 4 nodes or 5 nodes, all nodes will shut it down. But if you are using a single, if you want to stop only one instance out of 4, you can use -i instance name, instance number 1, instance number 2, like that you can able to. So that's all about this video, guys. In our next video, couple of RAC DBA entry questions, we will share it. Thank you, guys.